Today we want to talk about some more derivative shortcuts. This has jumped all the way to chapter 3. Don't worry about chapter 2. We'll come back in chapter 2. We know what's in chapter 2. It's just rate of change. But I want to spend more time on it, but I want to be able to find some derivatives quickly using our shortcuts. Right now we have but one rule. The derivative of x to the n is nx to the n minus 1. The procedure is to multiply by the exponents and then subtract 1 from the exponents. It's only one rule, but it's a super versatile rule because there's a lot of things that we can write as powers of x. X to the fifth, the derivative of x to the fifth is 5x to the fourth. The derivative of x squared, we can write the x squared as x to the 1/2 power and do 1/2 x to the minus 1/2. We can write 1 over x cubed as x to the negative 3 and write the derivative as negative 3x to the negative 4. Multiply by the exponent, subtract 1 from the exponent. So we can read the square root of x as x to the 1/2. We can read it x to the negative 3, 1 over x to the third as x to the negative 3. We can even use the distributive property if we have something like 3x minus 1 squared. For reasonable amounts of algebra, we can just use the distributive property and write terms. So I could rewrite this. Now I still haven't done the derivative part. I'm just rewriting what I'm taking the derivative of. But we'll get 9x squared minus 6x plus 1. And then take the derivative a term at a time. Use the fact that the derivative is a linear transformation and just carry constant factors and separate by terms. So I have 18x minus 6 plus 0. So we have one rule and the fact that the derivative is a linear transformation and therefore respects scalar multiplication and vector addition. So that's one of the things that makes this one rule very versatile. However, this becomes kind of inconvenient if I have like 3x minus 1 all to the 7th power or something ridiculous. We don't want to multiply this out. Fortunately for our heroes, we have rules. We have ways of dealing with compositions of functions. So we have a rule called the chain rule. Now I know if you've looked at the schedule of events, chain rule isn't supposed to show up until chapter 4, but the secret is, chapter 3, section 4. And we've only talked about chapter 3, section 1, but the secret is we have been using the chain rule. It's just that the inside function was always x, and so the derivative is 1. The chain rule is for taking the derivative of a composition of functions. This is where we have one function plugged into another function. This is a composition of functions where one function is plugged into another function. So we have f of g of x. So let's make a couple of functions. Let's suppose that f of x is x cubed. And let's suppose that g of x is, use one that we've used before. Let's say f of x is x to the 7th, and g of x is 3x minus 1. I can write f of g of x I can write this as a composition of functions. F of something is that thing to the 7th power. So f of g of x is g of x all to the 7th power. So f of something is that thing to the 7th power. If that thing is g of x, then f of g of x would be 3x minus 1 to the 7th power. So in this case, 3x minus 1, the 7th power of the difference of 3x and 1 is a composition where 3x minus 1 got plugged into x to the 7th. G of x is 3x minus 1, says whatever's in the parentheses, do 3 times that, then subtract 1. So if I were to switch this around and find g of f of x, g of something is to take 3 times that thing and then subtract 1. So g of f of x would be 3x to the 7th minus 1. If h of x was some other function, let's say h of x is sine x, then h of f of x would be sine of f of x, which is x to the 7th. Because h of x says sine of the thing. H of g of x would be sine of 3x minus 1. Because h of x says do sine of the thing. How if we flip these around and do f of h of x? The function f says do the seventh power of the thing. F of x is the seventh power of the thing. In this case, I would want the seventh power of sine of x. I'd want sine of x to the seventh power. This is not how we write the seventh power of the sine of x. We usually write sine to the seventh of x. That is just the notation that we chose for the seventh power of the sine of x. We, like I was there. We want a g of h of x. The function g of x says 3 times the thing minus 1. So I'd have 3 sine of x, and then minus 1. We got to be careful with our parentheses here. That minus 1 is after sine of x and after 3, multiplying by 3. Any questions? How's everybody okay? From an order of operations standpoint, that's all we're doing here is we're making sure we can read the order of operations. The problem is now that we're in calculus, now that we've been through trig and we know about exponential functions and logarithmic functions and some other transcendental functions, that whole PEMDAS thing, that whole PEMDAS bullshit that we had for order of operations is out the window. That may have been useful back then, but it's no good anymore. Because where does sine fit into PEMDAS? And it's an order of operations. Here's what you do with all these operations. Parentheses is not a fucking operation. Why is that in the order of operations? PEMDAS is trash. The reason is not because it doesn't work, but because you're better than that. PEMDAS is a rule, treats you like you're a fucking machine, and you're better than that. You are better than a machine. So that's why we can only do that to little children, right? Because apparently in our society, it's okay to disrespect children. All right, children, this is what you're going to do. Why? Because we said so. Okay. I mean, in our defense, it works really well. But PEMDAS is trash. And every time you see PEMDAS on your social media feed, you should block the person that posted it. Because they're just trying to start fights. Can you solve it? And it's like, well, 6 divided by 2, parentheses, 2 plus 1, close parentheses. And then there's a bunch of people answer it like fighting. It's like, well, it's 9, it's 1, it's 9, it's 1. Everybody has missed the point. You should all band together, gang up on the person that posted that question and said, why are you asking such ambiguous questions? And like, oh, I'm just asking questions. Anybody who says, I'm just asking questions, kick their ass. Not physically, like verbally. Berate them. They're just trying to start a fight when they posted that meme. They are just trying to start a fight. And so if you just try to answer the question, That's what they want. Don't do that. Block that person. Tell all your friends to block that person. If you see them physically in real life, ignore them. Just like when they walk up and they say, "Hi, how's it going?" You just ignore them. They don't exist anymore. Persona non grata. You know what I mean? Everybody knows what I'm talking about? The correct answer is not 9. The correct answer is not 1. The correct answer is all fuck off. That's the correct answer. Stop disturbing shit. It's about order of operations and reading what you do. Take X, first thing happens is sign, then we multiply by 3, then we subtract 1. In this one, the first thing we do is X to the 7th power, then we find the sign of the result. In this one, we take the sign of X first, and then we raise to the 7th power. It's just about reading. Math is this huge reading exercise where we have weird notation for things. If you think it's weird that we have weird notation for things, look at the sign over there. It says, what is data science being used for? What a weird bunch of symbols that we use. But we throw them together in a certain order, in a certain way, and it has meaning. Same thing here. So let's talk about how to use the chain rule to find the derivative of a composition of functions. Incidentally, if you were the person posting that meme, just knock it off. I mean, just knock it off. You're just trying to start a fight. So let's talk about what the chain rule says. The chain rule says the following. We want to take the derivative of a composition of functions. F was green, I think. So I have this composition of functions. I don't want to find the derivative of it. I'm going to use prime notation. So the derivative of f of g of x, the derivative of this composition of functions. Here's how it works. We take the derivative of the outside, the derivative of f, we find f prime of g of x. And then we multiply by the derivative of the inside. A lot of shorthand in that. Sometimes it's phrased like this. Take the derivative of the outside, leaving the inside alone. That's another way I might say that as with respect to the inside. Then multiply by the derivative of the inside. So I'm referring to g of x as the inside. And f is outside. Not a great description of the chain rule, but I have to admit it's effective because it was like 1989 when I first encountered this, and I'm still stuck with the words. So I'm like, all derivative of the outside, leaving the inside alone, times the derivative of the inside. F prime of g of x times g prime of x. This is not the only way we'll encounter the chain rule. We might see it at, if we have dy dx, we say dy dx is dy du times du dx. So let's see some examples of this. Chain rule is all about a reading exercise. We have to be able to separate things into an outside and an inside. Think outside is like the big picture of what's happening, and then the inside is what happens before that. So what is the order of operations in this 3x minus 1, or this 7th power of the difference between 3x and 1? What's the first thing that happens to x? Multiply by 3. After we multiply by 3, what do we do? Then subtract 1, and then to the 7th power. So we can see the three things that are happening in this. So let's think about what we don't want to deal with as far as multiplying this out. The part that we don't want to deal with is that 7th power. I don't want to write 7 copies of 3x minus 1 and then start multiplying things out like a superfoil problem. With 7 of them, there's like a first, there's one outer, and then there's a last, but then there's like a bunch of inner stuff. F-O-I-I-I-I-I-I-I-I-I. Foil is kind of what it boils down to. Like Flavor Flav math class. Foil. Don't want to do that. Also, don't want to find that 7th row of Pascal's triangle and deal with the 3 and the alternating signs. No, forget it. We're going to use the chain rule. So we're going to think of an inside function. We're going to think of the inside as being 3x minus 1. This is something to the 7th power. This is thing to the 7th power. And so I'm thinking inside is the 3x minus 1. And then this 7th power is the outside. Outside is stuff to the 7th power. So the chain rule says take the derivative of the outside, leaving the inside alone. Take the derivative of the outside with respect to the inside. So the derivative of something to the 7th power is 7 times that thing to the 6th power. In this case, that thing was 3x minus 1. Take the derivative of something to the 7th power, 7 times that thing to the 6th. Then multiply by the derivative of the inside. The derivative of 3x minus 1 is 3. Let's throw in a new color. So if the inside is 3x minus 1, one of the pieces we're going to need as a factor is the derivative of the inside. The derivative of something to the 7th power is 7 times that thing to the 6th power times the derivative of that thing. Any question? Yes. Say that again. Not necessarily, because this one worked out, was easy to describe because there was only one x. My next example kind of fights against our description of what happened. I see what you mean. Now I see what you mean. No, not necessarily. Now we might want to simplify this because I got this 3 separated out, so we can call this 21 times 3x minus 1 to the 6th power. This is most likely how we would write our answer, but this is how we arrive at it. Yes. Oh, you're right. C is not equal. The function is not equal to its derivative. Thank you. Here I have the same outside function. I have something to the 7th power. That's the big picture of what's going on. And we can see that the inside is x squared minus 5x plus 2. That's our inside. So we're thinking here's our inside. Our outside is something to the 7th power. So the derivative of y with respect to x will be the derivative of the outside with respect to the inside. The derivative of something to the 7th power is 7 times something to the 6th power. Then we multiply by the derivative of the inside, the derivative of something. Questions? One thing to keep in mind is that the chain rule is always in effect. It's just that the examples that we did last week, the derivative of the inside was always 1. Because we took the derivative of x to the 7th power, we did 7x to the 6th power times the derivative of x, which was 1. So life was pretty simple. The chain rule is always in play. The chain rule is always in play. No matter what you do on a problem, if you're finding a derivative and I say, did you use the chain rule on this problem? The answer is yes. And it's just at the end of all these problems, the derivative of x is equal to 1. So we don't write that. Any questions? How's everybody okay? Oh, yes, we can see how important this is. I know that in my future, when I'm working as an engineer for Lockheed or SpaceX or whatever going concern is working on the mission to Mars, so you're like, yes, I'm going to have to be using the chain rule to find my derivatives. Actually, I'm pretty sure that that's not the case. One thing to note is that you do have a derivative calculator, and you're carrying it around on your phone. So not on your graphing calculator, but you're carrying around on your phone. And the calculator that you're looking for is Wolfram Alpha. So the calculator that you're looking for is Wolfram Alpha. And if you put in things like 3x minus 1 to the 7th power, it can tell you all kinds of stuff about it. And if you just start scrolling, one of the things you'll find is the derivative. The derivative of 3x minus 1 to the 7th power is 21 times 3x minus 1 to the 6th. Keep in mind that although Wolfram Alpha will find derivatives for you, sometimes it writes them like a normal human would write them. Other times, it doesn't. And it's super obvious that you just copied off of Wolfram Alpha. I mean, it's so obvious. It's like when you just get an essay from ChatGPT. It's like super obvious that you did that. Because it doesn't write like a human. It writes like a machine imitating human. And right now, it's not passing the Turing test. Wolfram Alpha, sometimes on some problems will pass the Turing test and I can't tell. But other times it's super obvious. You'll randomly factor out a fraction, but not the exponential factor. And I'm like, oh, why the hell would you factor out a 1/9, but not the e to the 3x? Then I'll ask you that and you'll be like, oh, wait, what did I do? So it's just super obvious. I won't call you on it. I don't have to call you on it in Calc 2. You get called on it later on when you can't do anything. And you're in like Calc 7. You're like, well, we just do this. And you're like, oh, we do what now? And they'll be like, oh, the chain rule. The great thing is that that gets deflected off of you also. If you don't know how to do something later on in your analysis class, they don't look at you and say, Michael, oh my God, what's wrong with you? Did you cheat in Calc 1? They'll be like, oh, your Calc 1 teacher was bad. And you'll be like, oh, yeah, that guy sucked. Didn't teach me anything. And you're like, oh, dodge another one. You know what I mean? I won't hang out with previous math instructors much. All right, any questions? The chain rule is always in effect. Take the derivative of the outside with respect to the inside, multiply by the derivative of the inside. It's a terrible shortcut language, but you need to find some kind of set of words that will make you take separate this out into what one function being plugged into another function. That's what we're trying to separate out. What's being plugged into what function can I use for the g of x that's sitting inside this outside function that I'll call f of x. Question? So we multiply by the derivative of what's in here. So 7 times 3x minus 1 to the 6th times the derivative of 3x minus 1, which is just the 3. In the second one, the inside was x squared minus 5x plus 2. So the derivative of that is 2x minus 5. We multiply by the derivative of the inside. Any questions? It happens every time. I'm just kidding. All right, that's going to do it for today. Remember, the chain rule is always in play. If you can't access homeworks 6 through 9, please let me know. If you can't access homeworks from chapter 3, please let me know. That's it for today. I'll see you all on tomorrow, but have a good day, and thanks for playing.